if you're a wet lab scientist and you deal with any amount of code, whether that's some one-off script that a colleague sent you or a code notebook for running an RNA-seq analysis, you're dealing with code, you know that you probably should be using Git. But Git has a really steep learning curve for people. It's hard to understand why it's important until it's important. And to see its value, you really have to be using it. But again, there's that steep learning curve, so why put in the effort until you see the value? So I'm here to tell you, yes, you should be using Git for all of your code and for everything else from my perspective. I use it for manuscripts, I use it for my CV, all kinds of stuff, but definitely for code. And this series of tutorials is going to try to walk you through what Git is, why to use it, and how to use it effectively. So in this first video, we're just going to sort of talk about what Git is and how it works and why it's useful. So let's get started. So on my screen here, I've got a couple of different windows up that we're going to walk through. So over here on the left is a graphical user interface to Git. This one is called GiddyUp, but it's one of many. There's others like GitKraken, GitHub has one. You have a bunch of different options, graphical user interface. Over here on the upper right, I've got just a file system. This is a Linux file explorer, but if you're on a Mac, this would be something like Finder, or on Windows, it's Explorer. This just shows you the files in a particular directory that I'm using. And I've got two terminals open. One is going to be to show the Git commands that I run. We'll sort of mirror the graphical user interface and the command line interface. And then here, I'm going to use a text editor that I use from the terminal. But for this, you can use VS Code or whatever text editor is comfortable for you. You should be really using a plain text editor, not something like Word or Google Docs for code, but that could be TextEdit, it could be VS Code, Posit, or RStudio. Any of those will work just fine. I'm going to use NeoVim, but you don't have to worry about that. So here I have a folder right now, imagining that you have some folder that has some code that you now want to use version control on. So here I've got a couple of text files, a README file, and a little Python script. And we'll show you the details of those in a sec. But this directory right now is not controlled by Git. So how do we get started? So if you're using the graphical interface here, probably there's a way to initialize a new repository. So the term in Git for starting is initialize. So here, if we click on this, we could go find the directory here, and we could choose that, and it will initialize it. From the command line, if you're running there, the command to do that is git init. And if we do that, you'll see here, we've initialized a Git repository in this directory. And what Git is it's just a set of text files that give your directory superpowers if you're using Git. Over here, you can't see what that is. It's because the thing that controls Git is in a directory that starts with this period. And what that does on Unix file systems is it makes it a hidden folder. In your Finder, you can probably somehow show hidden files. And here, if I do that, you can see that now I have this Git directory here. Or if you're comfortable on the terminal, you can use ls and say -a for all. And then you can see here, there's that Git hidden Git subdirectory here. If you just do ls, that directory doesn't show up. So over here, instead of initializing, I'm instead going to say open existing repository. And again, I'm going to go to this Git tutorial folder. And what you'll see now in my graphical user interface is I have what are called unstaged files. What that looks like from the command line is if I do git status. And git status tells me some information about branches and commits, which we'll talk about. And then again, it says here, untracked files. You can see these 4 files here that Git doesn't know about yet. It knows that they're there because it can look at the file system, but it doesn't know, it's not tracking them, it's not paying attention to them. So in Git, the way to tell Git that you want to track a file, that you want to keep track of the versions of a file, is to add them. So I'm going to show you on the command line here. If I say git add readme, for example, what you're going to see is that this readme will go from unstaged to staged. Okay, so sometimes you have to refresh here. So now you can see that this readme is staged. And over here on the, let me shrink this window there, you see a bunch of green here. That's because what Git is tracking is that I have added now 7 lines of text in this readme file. So green is for adding, red is going to be for subtracting. We'll see that in a sec. And these other files are unstaged. If I do git status again from the terminal, it tells me the same thing. I have changes to be committed. Those are called staged files. And I have these other untracked files. I'm just going to go ahead and add all of these files to be committed. Here I'm just checking them in the graphical user interface. Over here, I could have said git add and listed all of these files. And again, now if I say git status from the terminal, you can see now all of these changes are to be committed. So this graphical user interface is just doing the same things that you could do via the command line. And Git, it's storing the information about files to be staged, additions, etc., in that Git subdirectory that we looked at earlier. And I'll show you the structure of that later, but for now, we're just going to focus on the basics. These stages, or these files rather, are not yet committed. They have not yet been tracked by Git. In order to do that, we have to commit them. Over here, you can see there's a commit message. We can do this as our initial commit. You can add whatever you want. It's usually good to use descriptive commit messages. And then we can say commit here. If we want to do this from the command line, given that we have these staged files, instead we can say git commit. And then -m is the flag to add a message from the command line. So again, we'll say first commit here. So if I run that, these files, the command line tells you they've been committed. Over here in the graphical user interface, if we refresh, we see these files are all committed. And now if I say git status, we have nothing to commit. Git is aware of all of the changes to this repository. The other thing you'll see over here now is that I now have this first commit that is tracked. So one of the nice things about having a graphical user interface is it's going to show us the tree of all of the changes that we're making. We'll get into that in a future thing. So let's come back here and say, okay, what if we make a change to a file? So here I'm going to open up my my text editor. Again, this could be just something like VS Code. And I'm going to say, add an exclamation point to this. Yay, we're learning dry lab skills for wet lab biologists. So I'm going to save that in my text editor. And now what happens over here? We now see that I have a change in my README file. We have deleted this line and added this line. And this graphical user interface helpfully tells you there's just one character of that line that's been changed. But the way that Git tracks versions is line by line in plain text files. So we can't only track that I've added a character at this position. It says line 3 was deleted and line 3 was added. That's different. The graphical user interface tells me it's just that one character. But Git is tracking that entire line of code. If I look on the terminal, git status, it tells me that this README was modified. So again, I can add this here, give a informative commit message, add exclamation, I can type, commit. And now you see we've added another commit on top of our first commit. If we refresh, this is the diff from the previous version, so the difference. If I look at git status, we're on our main branch and there's nothing to commit. So this is the primary workflow for Git. We modify some files, we add them to be committed, either by staging and then committing, or we can just commit directly if we're using the command line, which I'll show in a little bit. But that's basically the process. And Git is keeping track of all of the individual changes as we go through. I can see this same information again from the command line. If I say git log one line, we can see here the commits. This right here, head main, this is basically where the directory is currently pointing. And we see also our first commit. These little numbers here are what they're called the commit hash for that particular commit. This allows us to track every single change that has been made from the beginning of the repository all the way to our current status. To show this, again, what I'm going to do is I'm going to add another file here. So if I say, I'm going to copy this to file3.txt. And when I do that here, I've added, you can see it shows up here, but Git isn't tracking it yet. So over here in my history bar, you can see I have uncommitted changes now. This file3 has been created. If I add it, I'll do it from the command line this time, git add file3, git commit m added file3. And then because my Python file is paying attention to the files that I have in the directory, I'm going to go ahead and add file3 to this list. And this is an important part of Git, is that Git doesn't just track the versions of each individual file, it tracks the state of the entire directory. So once I commit this, I'm going to actually say, so I added file3, but I'm going to add an additional little file here, am. What that does is it says, commit any files that I have initially tracked. Before I do this, I'm just going to show off git status from the command line, git status. So you can see here, we've added a new file to be committed. That was this command. But it knows that I've modified this file because we were previously tracking that file. So any file that's been previously tracked, Git is going to notice if there's been a change to it. So if I say git commit -am, add file3, it's going to commit every file that has been previously modified, as well as anything new that I've added. It will commit all of that. We could do each thing individually, but because a lot of times code is interacting with different files, so we change one file, we have to make a change in another file. We want to be able to track the state of all of that together. So I don't want to have added this file3 to my Python script unless that file exists. So I'm going to go ahead and commit everything. Say git status again, just so we see working directory clean. And if we come over here and refresh, now we have this third commit here where we added a file, we modified another file, and that's the content of this commit. Something to pay attention to is that Git tracks all of this, but if we move to a previous state, sometimes files will look like they disappear. So most of the time you don't pay attention to individual commits, you use branches and stuff. We'll get into that in a little bit. But here I'm going to copy, or I'm going to tell in the GUI interface, I'm going to say check out this commit. So check out is Git's version to say, like, we're going to move what we're paying attention to another state of the repository. So if I check out this, what you're going to see is over here, file3 is going to disappear. So I've checked out this commit. Now you can see this little green thing is where my current head is at. Don't worry about what detached means. We'll get into that later. But file3 has now disappeared. If I look on the command line, I don't have file3 here because Git is pointing to this previous state of the repository where file3 didn't exist. Let's say git checkout main, which is the branch. We could also give it this commit hash, but if I check that out, now we're moving our head position to main. If I refresh over here, you'll see that update, and we're here, and file3 is back. So file3 didn't go anywhere. It was always stored in the history, but we've now gone back to a state where file3 does exist. I'm going to show one more thing here. I'm going to create a new file. Let's do it from here again. We'll copy file 1 to say file 4.txt. And then without committing file 4, I'm going to jump back to a previous state. Check out this. So I'm back to this detached head. And now, if we look, file 3 is gone, but file 4 is still there. Why? Because Git doesn't touch files that it doesn't track. So when we moved from our third commit back to our second commit, file 3 went away because file 3 had been tracked as a change from commit 2 to commit 3. But Git won't touch files that it's not tracking. So if we check out this other commit, file 4 exists, but it's not being tracked. So Git knows that it's there as an untracked file, but it won't remove it if we move around. So again, I'm going to check out main, come back here. I'm going to say git add file 4 to be changed. I'll update my Python script here. File 4. This is bad programming. You wouldn't do it this way in real life, but just bear with me for a sec. We'll do that. We'll say, this time we'll do it via the GUI. So this one's already added. We'll add the modification here, update file 4 in script, commit, and we've now got our fourth commit. So this is the basics of Git. We add files to be tracked. Git pays attention to their status. We can move back and forth along this file tree to access different states of our code at any given time. And this can be extremely powerful in ways that we'll show in a little bit. But for now, you've seen how to initialize and start tracking files. In the next video, we'll talk about how to use something called branches in order to try out different versions of your code, but make sure that your stuff stays organized and you don't ever end up in a state where you need working code, but it isn't working. So I'll see you in the next one.